Good morning, everyone. I am going to quickly demonstrate how to do the calculations for the artificial data that was generated as it pertains to the zebrafish experiment. So again, what you have been asked to do is to calculate the micromoles of CO2 produced by the zebrafish per gram per hour. And so I gave you some artificial data looking either at cold fish, the temperature of cold water on the fish, the rates of cell respiration, the effects of caffeine on cell respiration, and the effects of music on cell respiration. And so you were supposed to pick one of the three of those. For demo purposes, I made up a new fake set of data, which is looking at the effects of watching coronavirus news media that is streaming on the cell respiration rates of these poor fish. All right, so a couple things to point out. One is that in order to do micromoles of CO2 per gram per hour, that means we need the grams of the fish. How much did the fish actually weigh? And so I've given you that information here. For instance, I say 1.85 grams of fish were added to a beaker that contained the pink solution while CNN News was streaming on coronavirus. Okay, so that's our fish who are watching the news. So the mass here, go ahead and add a label here and type in for fish watching the news, we used 1.85 grams. For fish who were not watching the news, we actually had 1.45 grams of fish. So let's put that here. Okay. The other thing is, again, if we're doing micromoles of CO2 per gram per hour, it means we need our time in hours, but right now what you have our time in minutes. So let's go ahead and make that calculation. So you can basically just take 10 divided by 60, or you can have Excel do this for you. So you say the value in cell C9 divided by 60 is 0.167 basically. And now we can just copy and paste that, and it's going to do it for the different amounts of time. Okay, so now what we're going to do is actually figure out the micromoles of CO2 per gram per hour. So to do that, we need to take the VC minus the VE. So we'll do our equals function. VC is in cell D9 minus VE, which is in cell E9. And we're going to divide that by the mass of the fish, which is in E13, times the time of the experiment, which is G9. And this should have been in parentheses. All right, and so now what you can do, let's see what happens when we copy and paste this. We might have to fix things a little bit. All right, so let's look at what it was assuming. So for this experiment, it did D minus E, and then the correct time, but it moved the mass of the fish down. So we need to just fix that. So this should be E13. And now if we do that again, we're going to have to fix that one more time. So let's look at this. Did the correct time, but we need the mass of that fish corrected. Again, E13. Okay, so now we have the micromoles of CO2 per gram per hour for the fish who were all watching the news. And now we should be able to copy and paste this. And let's see, it's doing something wrong. We can fix our table pretty easily. So now what we need to do is change this back to D9 minus F9. Then this should be G13 or F13 minus G9. So again, you can do this on your calculator if you would rather. I find it in general easier to just use Excel to do this, but you also need to feel comfortable doing it. All right, so now we have our values for each of these experiments. And so the last thing to do is to go ahead and figure out the average of trials 1, 2, and 3. So to do that, we're going to hit our function again, which just means you start with equals and type in average. You're going to highlight those numbers. It'll give you the average of your data, and now we can just copy and paste that, and it's figured out the average of the values for the fish without the news. And then we need to do standard deviation. So you're going to hit equals standard deviation. Go ahead and figure out the deviation in your data. Do that for both of those sets. And then lastly, we need to run a t-test. So you're going to say equals t-test, and we need to figure out array 1, which is going to be the fish with the news. And then you do comma, and then you do select array 2, comma, 2, comma, 3. All right, and so now it gave us a p-value of 0.04, which is less than 0.05, so that would say this is statistically significant. All right, and then the final thing we need to do is go ahead and plot this data. So we're going to do that with our average numbers. So go ahead and highlight your data labels, and we're going to do insert. We're going to insert a bar graph. And this is looking good so far, but we need to add our standard error bars. So I'm going to select the data and then add a chart element. And the guidelines for how to do this is all in your lab manual. More error bars, custom, specify value. And right now it's saying the error bars are plus and minus 1, which is not what we got for ours. So you need to delete these numbers. And we're going to put in what is the actual error bar. So you'll select that little the Excel table, and we're going to put in our values for the standard error. And now we're going to do the negative error. It's the same numbers. Hit OK. And now you can see our error bars really changed. So for the fish with the news, the error bars are really small, just 0.268, so plus or minus 0.268. It was a little bit bigger for the fish without the news, and you can see our error bar is actually bigger. All right, the last thing we're going to want to do is actually add our titles to our axes. So here, what this is actually looking at, what we plotted were micromoles of CO2 per gram per hour. And the title for this, we should say something like amount of CO2 produced by zebrafish in response to news cycle on coronavirus, something like that. All right, so hopefully that was helpful. This could be, you could label this as maybe treatment, or the different treatments that you did, and then that should be good to go. All right, I hope that was helpful, and I look forward to seeing your analyzed data, not on this one, but on the ones that you picked. All right, take care.